Solving problems given the graph of position, velocity, or acceleration is the same thing that we did in the graph analysis unit, except that now things are labeled slightly differently. But we're still going to be using that same chart that we had. The only difference is that F is now called position, F prime is velocity, F double prime is acceleration. So I'm going to start by sketching over here. So right now we have position. What do I do in purple? This is F. And going along with it, notice we're being asked about velocity. And later on, I'm just going to tell you there's some asking about acceleration. So position, we know that we can find out concavity. I guess these all start at 0. We know that this will translate to increasing, decreasing, and plus minus, and that this will also translate to plus minus. Exact same thing that we've been doing before. Let's see, we're told there's an inflection point here at 4, concave down, concave up, increasing, decreasing, positive, negative, looks like it crosses at 4.5 and 7. So when we translate those over, let's see, concave down, decreasing, exactly the same as we did for graph analysis. So over here, we're being asked for what values of t is the velocity positive. So I go to velocity, let's see, that was starting at 0. So I go to velocity, and I say, I just look for the positives. When t is between 0 and 2, or t is greater than 6. And how do we know that? Remember, we need to refer back to what we're given, which is position. So we know that because position is increasing. The trickiest thing about this is simply figuring out what the question is asking for. Other than that, it's basically just what we've been doing. So for what values of t is velocity increasing? Velocity increasing when, right here, t is greater than 4. Because what were we given? We were given position is concave up. And so on and so forth. Notice we can also be asked about acceleration. When is acceleration negative? Well, here. When t is between 0 and 4. Oh, I really ought to be putting the units in here. That's seconds. Because we were given position is concave down, sometimes this is where it's really important to memorize that list that we looked at earlier. When is the particle at rest? This is where you have to remember particle at rest means velocity equals 0. It's the same as where velocity is changing sign. So that occurs at 2 and 6. And that's because position changes direction. When is the particle, or when does particle change direction? We actually just answered that here. It's changing from increasing to decreasing and vice versa. But if we think about it in terms of real world terms, we're talking about it changes from moving left to moving right, or vice versa, meaning velocity is changing sign. So that was the same as this one above. Right here, velocity is changing sign at t equals 2 and t equals 6. We can also look at something like when is the particle moving right. Again, just memorize what this is. Moving right means positive velocity. We look up here, positive velocity, 0 to 2 and greater than 6. And we can be asked about maxima and minima before. When does velocity have a minimum? Well, if we look up here, it's not terribly clear from the question whether that's an absolute or a relative minimum, but there's only one minimum, and it's both a relative and an absolute one right there, so it actually doesn't matter too much. So velocity has a minimum at time t equals 4 seconds, because position is changing from concave down to concave up. We can also do these problems when we're given a graph of velocity. So like here, the velocity of a particle that's moving on the x-axis is shown at right. When is the particle moving to the left? So here we've got velocity. We might be asked about position, we might not. We can do the whole chart just for kicks. So velocity is f prime. Position corresponds to f. Acceleration is f double prime. So we know velocity. And I always like to do this. I like to not notice that it starts at 0. Okay. So we know this corresponds to concave up, concave down, and this to increasing, decreasing, though we don't know if we're going to need it yet. Acceleration. Okay. So, velocity, up until 2, it's neither concave up nor concave down, it's straight. And then it's going to be concave down, and we're told there's an inflection point at 4, then it's concave up again. Increasing, decreasing, it's clearly increasing until 2, decreasing again until 5, increasing after that. Zeros at 0 looks like about like 3.8 or something. Oh, we can estimate that. And then again at about 6.8. Positive, negative, positive. When is the particle moving to the left? That means velocity is negative. Just got to memorize that translation. So from approximately 3.8 seconds to 6.8 seconds. And there's no real actually there is, because velocity is negative. Another question we could ask is, when is the acceleration negative? So that means we do need the plus minus for acceleration, so that's 2 and 5. Actually, we can just do our normal interval notation. When t is between 2 and 5 seconds, because velocity is decreasing. And finally, when does the minimum acceleration occur? Relative minimum means I need this line up here. So straight line means acceleration is 0. Acceleration is a constant. In this case, the slope of the line is a constant positive, so it's flat. Then concave down, it's decreasing. Concave up is increasing. So when does a relative minimum occur? When we have this switch from decreasing to increasing at t equals 4.